let's take a closer look at rotations. And again, how can we apply our knowledge of the Cartesian plane and ordered pairs to help us understand this transformation a little bit better? When a shape is turned about a point, and we always say about a point, not around a point, we call that a rotation. So it is rotated. And each quarter turn represents 90 degrees. So here we see a quarter turn represented by the hands on this clock. A half turn is 180 degrees. A 3/4 turn is 270 degrees. And a complete turn measures 360 degrees. Now, it can be really helpful to think of the hands of a clock when we visualize rotations. That's why this is a clock image that I chose to use here. In these images, the hour hand is rotating in what we call the clockwise direction. And we call this direction clockwise because it is the same direction as the movement of the hands on a clock. So this direction represented by these arrows, here, 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 and here. That direction is called clockwise. Here's another way of visualizing rotation. That guy looks like Pac-Man there. Okay, so this one, we are going to go in a counterclockwise direction, and we call it counterclockwise because it goes counter or against the clockwise direction. So it's the opposite to clockwise. Now, remember that when a shape is turned about a point, it is rotated, and each quarter turn represents 90 degrees. So here's our first quarter turn, 90 degrees, our half turn, 180 degrees, our 3/4 turn, 270 degrees, and our full turn of 360 degrees. A complete turn measures 360 degrees. Now, let's watch an animated version of a full 360-degree rotation just to make it all make sense. I hope these angle names are bringing back some memories from our angles unit. All right, here we have a lovely trapezoid. Trapezoid PQRS was rotated a turn clockwise. Sorry, it was rotated a 3/4 turn clockwise about vertex R. So the point of rotation could be a vertex on the shape, or it could be a different point that's not on the shape at all. The rotation image is trapezoid P prime, Q prime, R, S prime. And after a turn clockwise, the reflex angle between R and S, RS and R prime, S prime is 270 degrees, the same as a 3/4 turn there. Alrighty, now let's look at the table of values. A really important thing to notice here is that since R is a vertex on the trapezoid and the image, we don't label it vertex R prime in the image. Now, I think I messed up and called it R prime back there, but we actually just label it R. So we have P prime, Q prime, R, S prime. Alrighty. The sides and their images in a rotation are related. So let's take a look at this one here. The distances of S and S prime from the point of rotation R are equal, such that SR equals RS prime. And that's what these, so SR equals RS prime. And that's what these hash marks here in the green tell us that the line segments are equal. In addition, angle SRS prime equals 270 degrees. And that makes it a reflex angle because it's greater than 180 degrees. And you'll notice that we use that little symbol that looks like an angle to represent an angle, just like we used with the triangle. It just saves us writing it out, and it tells us that this shape is an angle. After a rotation, a shape and its image may face different ways. So here is our trapezoid PQRS again. And after 1/4 turn, the shape is facing in a different direction. After a half turn, it's facing in still another direction. And after a full rotation, it's facing in, or sorry, after the 3/4 turn, not quite a full rotation, the 3/4 turn, it's facing in still another direction. So since we traced the shape and used the tracing to get the image, we know that the image and the shape are congruent. And again, congruent means all sides and angles are the same. Let's sum up what we covered in this lesson. It was a long one. I can identify 3 geometric transformations: a translation, a reflection, and a rotation. And here we go. This is our translation, our reflection, and our rotation. And we're not using those old words. We're only using translation, reflection, and rotation in grade 6. I can use ordered pairs and addition or subtraction to figure out where the vertices of a shape's image will be on the coordinate plane after a translation or reflection. And if you recall, we were able to figure out what the x-axis value of all 3 vertices would be by adding 5 to the original x-axis value. And we added 5 because as we move to the right on the x-axis, the values increase. So a translation or slide of 5 units to the right will increase that x-axis value by 5. And we were able to figure out the y-axis values using the same strategy. When we move down on the y-axis, the values get smaller. So to figure out the new coordinates for the y-axis, we subtracted 2 from the original. And that helped us figure out what all of the ordered pairs were for our translation image of triangle ABC after a translation of 5 units right and 2 units down. Pretty neat trick. I know that the vertices of a shape's image are marked with the prime symbol. For example, the image of quadrilateral ABCD is A prime, B prime, C prime, D prime. I know that congruent means that the corresponding sides and corresponding angles are equal. I know that clockwise rotations move in the same direction as the hands of a clock, and counterclockwise rotations move in the opposite direction. So here's our clockwise rotation moving. The hands are moving in the same direction as the hands of a clock, and counterclockwise goes the opposite way. And there's the image showing you that. Don't get dizzy.